on your stoichiometry problems. For your second type of stoichiometry problems, we're going to look at moles and grams. And as we look at the moles versus grams problems, we made the foldable in class, and that is pretty much going to be the most helpful with these problems, especially when you're getting first started with them, because a lot of times people struggle with, they don't know where to start or end. Usually people are great with mole to mole. When you get to the test, though, you think, oh, these are too easy. I don't really know what's going on. Or you try to make them more complicated. And then when we do gram to gram in the next video, you're great with those because it's the same process over and over and over. But when you have a different starting point and a different ending point each time, it gets a little bit more confusing. So like I said, that's why this is helpful. With the foldable, we went from grams to moles by using the molar mass. Remember, moles are the key to any Stoich problem that we do. So when we're doing any type of Stoich problems, you have to get to moles. That's because you have to use the mole ratio. The mole ratio is what flips you from one compound to another in a reaction. So if you're starting with, I don't know, hydrogen and oxygen, you're making water, and you have 3 grams of oxygen, we want to know how many grams of water you're going to make. You have to get to moles to get to that mole ratio, because that's how you change from one component to another. So when we're looking at these, we're going to go from grams to moles by using that molar mass, where you find the mass on the periodic table. Then, once you use your mole ratio, then you can go from moles to grams, again by using the molar mass of your second compound. So you're going to be finding 2 molar masses eventually with your problems. Now these flaps do fold down, so you can cover them up. So in the last video, we went from moles to moles of your given to your unknown. And as you go from one component to another, you have to use your mole ratio. Now today what's going to happen is they might not give you moles, they might give you grams. And if they give you grams and they want your answer in moles of your new compound, you're going to have to get rid of grams and turn it into moles. And then you can use your mole to mole ratio to go from one component to another. Or they might give you moles to start with, which is great because then you don't have to do the extra step. If they give you moles and they want your answer in grams, you're going to go straight to your mole to mole ratio because you already have moles, that step is done. Then you're going to get rid of your moles and go to grams by finding your molar mass of whatever you need to solve for. So a lot of times this is helpful because you can flip these down. And you can kind of go back and forth however you need to. If this is not helpful, you don't have to use it. That's up to you. That's the great thing about chemistry. There's tools that you can use, but not everybody needs them. So what I mean by that is in your question here, it says how many moles, so I'm solving for moles, of sodium sulfate, so I need moles of this guy right here, will be formed if you start with 222 grams of sodium hydroxide. So sodium hydroxide is right here. So I'm starting with 222 grams of this. I want to know how many moles of that one I am going to make in the end. Your first step, anytime you do these problems, you have to have a balanced reaction. So in order to balance this reaction out, remember you add coefficients to the front, like here. When you are balancing these, just the first one that kind of jumped out is I have 2 sodium here. I need 2 sodiums down here. So I'm going to put a 2 right there to balance out my sodium. So I have 2 sodium and 2 sodium. My sulfate, the SO4, I have 1 and 1, so those are already balanced. Now my oxygen, remember this oxygen is part of sulfate, so I'm going to ignore that one. But right here I have 2 oxygen. I need 2 oxygen down here. So I'm going to put a 2 right there. That gives me 2 times 1 is 2 oxygen. But now that changes my hydrogens to 4. I have 2 hydrogen right here, but wait, I have 2 right here. So that is actually a balanced reaction with just that 2 in front of the water and 2 in front of the sodium hydroxide. In front of these, there's 1s. They're ghosts, but for Stoich, usually at the beginning, it's helpful to write them out. So we're going to start with 222 grams of sodium hydroxide. When you start with that 222 grams of sodium hydroxide, I don't have moles. If I don't have moles, I have to get rid of moles. I'm sorry, I have to get rid of grams and turn it into moles, sorry. So in this one, I'm given grams. I want moles, so my unknown value is moles. So my first step, I need to get rid of my grams, turn it into moles by using the molar mass conversion factor. The molar mass conversion factor, I'm going to take the mass of sodium, which is 22.99, plus the mass of oxygen, which is 16, plus the mass of hydrogen, which is 1.01. So when I add all of that together, my conversion factor says 1 mole is equal to 40 grams. So I just added all of those components together. So, sorry, I need my calculator. I'm going to use that in this step. The mass of sodium hydroxide, NaOH, has a mass of 40 grams in 1 mole. So what I did was I took my grams and turned it into moles. Once I have moles, then I'm going to use the mole ratio, which comes from the balanced reaction, to go moles of given to moles of my unknown. So that's where I'm going to look at my balanced reaction. And in my balanced reaction, it says for every 2 moles of NaOH, because NaOH goes on top, the moles of NaOH goes on the bottom, and that's equal to what I'm trying to go to in the question. And it says how many moles of sodium sulfate. So here, for every 1 mole of Na2SO4. So in this question, we went from grams, we turned it into moles of sodium hydroxide. Moles of sodium hydroxide cancels, we turned it into moles of sodium sulfate, which is what the question's asking for. So now all I have to do is pick up my calculator and do the math. So to do the math problem, we're going to take 222 times 1, which is just 222, divided by, I'm going to open parentheses because there's more than one number on the bottom. So open up my parentheses, 40 times 2, and close it up. This first number out here has 3 sig figs. So my answer, I need to have 3 sig figs here. So when I get my answer, it's going to be 2.78. The unit that didn't cancel is moles of Na2SO4, which is what the question asked for here. Now, alternatively, if we look at this one, it says how many grams of nitrogen can be formed by the decomposition of 0.145 moles of ammonia. So we don't have a balanced equation. It says we're decomposing ammonia into nitrogen. Now, if it's breaking apart, the other component that it's breaking apart into is hydrogen. So when I have this, I need to balance out my reaction, because you always have to have a balanced reaction whenever you're doing these problems. So I can only put numbers in the blanks right here. Right now, the way that it sits, I have 1 nitrogen here, I have 2 here, so I need 2 over here. So if I put a 2 there, that gives me 2 nitrogen and 2 nitrogen. Now that does change my hydrogen to 6, 2 times 3. So I need 6 down here, which is 3 times 2. There's a ghost number 1 right there. I'm going to write it in just in case I need it. Now in this problem, we have moles given. Cover that up. I don't need to do that step. They already give me moles. They want to know how many grams of nitrogen you're going to have in the end. So in this one, I'm going to go straight from moles of given, turn it right into moles of my unknown. That's using the mole ratio. So I don't have to find the molar mass of ammonia because it's not necessary. So you have 0.145 moles of NH3. If you have moles, that's a good thing because you don't have to take your grams and turn it into moles. So we have 0.145 moles. That means that moles of NH3 is going to go on the bottom. Moles of what I'm trying to go to is going to go on top. The component that I'm going to, the unknown component, is nitrogen, moles of N2. So with this one, I have for every 2 moles of ammonia, I have 1 mole of nitrogen. Now in this problem, it does say that it wants grams. Right now I have moles, so I'm not done. I'm going to take this one step further. 1 mole of nitrogen. I'm going to turn that into grams by finding the mass of nitrogen on the periodic table. That mass of nitrogen on the periodic table for one of them is 14.01 times 2. So when I multiply that out, you end up with 28.02 grams for the mass of 1 mole of nitrogen. So, I don't know what happened. Why did that just... I'm sorry, I don't know what happened. So on this one, we have the 0.145 times 1 times 28.02. So when I get my calculator, I'm going to do 0.145 times 28.02. And then I'm going to hit divided by. This one is just 2 times 1, which I'm just going to ignore the 1. So divided by 2. Number out here has 3 sig figs. So I need 3 sig figs in my answer. So I'm going to get 2.03, and that's grams of nitrogen, which is what the question is asking for. So hopefully this makes sense. Like I said, this foldable is usually the most helpful when we're doing these problems, and this is usually where people get the most confused, other than percent yield problems later on. So as long as you have this, you can kind of help to fold down flaps and things like that. But if you are given grams, or you need grams, that's where you're going to use your molar mass. Any other Stoich problem, you're going to use your mole ratio. I hope that helps. If you guys have any questions, make sure that you email me. My email address is mgable@crosbyisd.org.